Today we are going to learn about energy. Energy is an important concept in physics because it explains how things move, change, and work around us. By the end of this session, you will understand different forms of energy, how energy works, and why it is essential in our daily lives. Energy is all around us. It is the ability to do work. Without energy, we would not be able to see light, feel heat, or hear sound. Imagine a world without energy. No sun, no movement, no life. Every single activity, like walking, eating, playing, requires energy. Work is done when a force acts on a body and the body moves in the direction of that force. For example, when you push a lawn mower, you are using your muscle energy to move it. Energy and work are connected. Energy is needed to do work, and doing work transfers energy from one form to another. Energy exists in different forms. The main forms include kinetic energy, which is the energy of motion, potential energy, which is the stored energy due to position, light energy, it is the energy that enables vision and powers photosynthesis. Then we have heat energy, sound energy. So these forms can change from one to another. For example, food has chemical energy that changes to kinetic energy when we move. The SI unit of energy is joule. 1 joule is defined as the work done when a force of 1 Newton moves an object 1 meter in the direction of the force. Another unit is calorie. 1 calorie is 4.18 joules, and 1 kilocalorie is equal to 4180 joules. Kinetic energy is the energy an object has because of its motion. A running child, a flying kite, or a rocket blasting off all have kinetic energy. Kinetic energy depends on two factors, mass and speed. The faster and heavier the object, the greater its kinetic energy. Let's compare a truck and a car moving at the same speed. The truck has more mass than the car, so it has more kinetic energy. Similarly, if two objects have the same mass, the one moving faster has more kinetic energy. So kinetic energy increases with both mass and speed. Potential energy is the energy an object has because of its position or state. It is also called stored energy. For example, when you pull a rubber band and stretch it, it stores energy. When you lift a swing to its highest point, it has potential energy. Here are some more examples. Water stored in a dam has potential energy due to its height. A drawn bow and arrow stores potential energy in the stretched string. This energy can be released to do work. For instance, water from a dam can generate electricity and the bowstring can shoot the arrow forward. Mechanical energy is the total of kinetic and potential energy. For example, a swing in motion has kinetic energy when moving and potential energy at its highest point. Similarly, a roller coaster has potential energy at the top and kinetic energy as it comes down. Mechanical energy is the sum of both kinetic energy and potential energy. Another example of mechanical energy is a pendulum. As it swings back and forth, energy changes between kinetic and potential, but the total mechanical energy remains constant. In a bouncing ball, the potential energy is maximum at the highest point. As it moves downwards, kinetic energy increases and potential energy decreases, but the total mechanical energy remains constant. Light energy is emitted by luminous objects such as the sun. It enables vision and powers photosynthesis in plants, which is essential for life. Light energy also converts to chemical energy in food. We use light energy in many ways: to see, to generate electricity with solar panels, and to power devices like bulbs and lamps. Light energy from the sun is essential for life on earth. It powers photosynthesis in plants, which converts light energy into chemical energy stored in food. Humans and animals indirectly depend on this energy when we eat plants or plant-based food. So sunlight is the primary source of almost all energy on earth. Heat energy, also called thermal energy, flows from a hotter body to a cooler one. Heat energy is used in cooking, drying clothes, generating steam, and even in power plants to produce electricity. It is one of the most commonly used forms of energy in daily life. Chemical energy is stored inside substances and is released during a chemical reaction. For example, chemical energy stored in wood is released when it burns. Chemical energy in food provides energy for our bodies. Chemical energy is also stored in batteries. Okay, so that chemical energy can be used to light a bulb. And chemical energy which is stored in petrol or diesel is used to run vehicles. So, it is one of the most versatile forms of energy, found everywhere from our food to fuels. Sound energy is produced when matter vibrates. For example, when you pluck a guitar string or a rubber band, the vibration creates sound waves that travel through the air. Sound energy is essential for communication, music, and warning systems. Without sound energy, life would be silent and communication would be very limited. Magnetic energy is the energy possessed by a magnet. Magnets can attract certain metals like iron, cobalt, and nickel. This energy is used in machines to move and lift heavy objects without manual effort. Magnetic energy is also used in devices like electric motors, speakers, and medical machines such as MRI scanners. A modern application of magnetic energy is Maglev trains. These trains float above the tracks using magnetic repulsion and can travel at extremely high speeds with very little friction. This makes them faster, smoother, and quieter than normal trains. It is an excellent example of how magnetic energy is used in transportation technology. Nuclear energy is released when the nucleus of an atom splits, fission, or when two nuclei combine, fusion. Nuclear fission is used in power plants to generate electricity. The sun's energy comes from nuclear fusion. Although nuclear energy can provide massive amounts of power, it must be handled carefully because it can also be dangerous. Nuclear energy can be destructive. During World War II, atomic bombs were dropped on Hiroshima and Nagasaki in Japan in August 1945. These bombs released enormous energy, causing massive destruction and loss of life. Even today, nuclear weapons remain a global threat, which is why scientists emphasize on using nuclear energy responsibly for peace and development. What did we learn in this session? Energy is the ability to do work, and it exists in many forms such as kinetic, potential, light, heat, sound, chemical, magnetic, and nuclear energy. Kinetic energy depends on mass and speed, while potential energy depends on position or state. Together, they form mechanical energy. Light and heat energy from the sun are the primary sources of life on Earth, driving photosynthesis and providing warmth. Chemical and magnetic energy play vital roles in daily life, from fuels and food to machines and advanced technology like Maglev trains. Nuclear energy is powerful and can be used for electricity generation, but also poses risks.